Okay, today we're going to change gears and talk about some transformations and some symmetry. So two types of symmetry we're going to talk about are line symmetry and point symmetry. So line symmetry occurs when you can draw a line through a shape or an object and fold that object on top of itself. So if we look at this parallelogram, there's no line that we can draw where if we fold the shape, it's going to line up perfectly on top of itself. But if we look at the isosceles trapezoid, if we draw this line right down the middle through the two bases, we could fold this trapezoid over this line and it would fold on top of itself. So this is what we call a line of symmetry. It's sort of like if we reflected this left side right onto the right side of the shape. Point symmetry is if we can draw a point on the object and rotate it some number of degrees, and then the object will look exactly the same. So if we put a point right in the middle of this parallelogram and we rotate it 180 degrees, it will look exactly the same. Of course, in order to be point symmetry, the number of degrees we rotate the object has to be less than 360, because if we rotate anything 360, it's going to be the same. This trapezoid, no matter how we rotate it, no matter where we put the point, we can't rotate it to make it look exactly the same, so it does not have point symmetry. So go ahead and pause here and see if you can determine in each of these shapes if they have point or line symmetry. So in this shape, there's no way that we can rotate it for it to look exactly the same, but we could put a line right down the middle and it will have line symmetry. So if we fold this shape over this line, it'll look exactly the same. In this shape, this hexagon, we have a point. If we rotate around that point, we can rotate it in several different ways so that it looks exactly the same as it is right now. And also, we have a lot of lines of symmetry. So all these lines, if I fold the shape over any of these lines individually, it's going to fold on top of itself. So this hexagon has multiple lines of symmetry and a point of symmetry where all those lines intersect. So speaking of reflecting, we're going to talk about reflections in the coordinate plane. And there are a few different types of reflections we're going to do. We're going to reflect over horizontal lines, like the x-axis. That's this guy down here. And also other horizontal lines that have the form y equals a number. So for example, y equals 3, which is 3 units above the x-axis. Y equals -6, which is 6 units below the x-axis. So these equations, y equal a number, are horizontal. Vertical lines like the y-axis, or lines like x equals -5 and x equals 2. And these two special lines, y equals x, that's this line that goes up to the right, or y equals -x, this line that goes down to the right. So let me show you what a couple of those look like. If I want to reflect over this line y equals -1, I go down to where y is -1, and I draw a horizontal line. That's my line of reflection. So every point, it's going to end up on the opposite side it started from. So if I look at point A, it's 1 unit above this line of reflection. So that means its new point, or its reflected point, is going to be 1 unit below that. And we name it A prime. This little apostrophe in math means prime. It means it's the reflected image of the original point. B is 3 units above the line of reflection, so B prime is going to be 3 units below. C is 2 units below, so C prime is going to be 2 units above. And now we can just connect those 3 points and the green triangle is my reflected triangle. Similarly here, if I have x equals 2, I go to where x is 2 and I draw a vertical line. A is 1 unit away from the line, so it's going to be A prime is going to be 1 unit away on the other side. B is 3 units away from this line, so on the other side B prime is going to be 3 units away. And C is right on the line of reflection, so C prime is exactly the same point. So I can connect those three, and there's my reflected triangle. Whenever I have trying to make a reflection on y equals x, all I'm going to do is switch the x and y coordinate. So you can draw the line y equals x, which looks like this. X and y are the same for every point, so 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth. If I take the coordinates for A, which are 3, 0, which I got from up here, or just by looking at the picture, I can just switch the 3 and the 0 to get 0, 3, and that's my new point A prime. The coordinates for B are negative 1, 2, so if I switch those, I get 2, negative 1, and there's my new point for B. C is 2, negative 3, so I'll just switch those and get negative 3, 2, and then I can draw my triangle. So for these horizontal and vertical lines, you can just do some counting to get the new coordinates. When you have y equals x, it's easiest just to switch the x and y coordinates to get your new coordinates. So this is an important thing to have down. I'll do a few more examples. Here I've got a new ABC. I want to reflect over the x-axis, so now I don't need to draw the line of reflection, it's already there. A is 1 unit above the x-axis, so A prime will be 1 unit below. B is 2 units above, so B prime will be 2 units below. C is 3 units below the x-axis, so C prime is 3 units above. And then we just draw our segments. For the y-axis, we count towards it. A is 2 units away, so A prime will be 2 units away on the other side. Similar for B, 4 units away. And for C, 5 units away. And then we can draw our triangle. So these points should be the same distance away from the line of reflection on both sides. For y equals negative x, I'm going to just negate the x and y values to get my new points. So A is 2, 1. So A prime becomes negative 2, negative 1. B is negative 4, 2. So it becomes 4, negative 2. C is 5, 3. So it becomes negative 5, positive 3. And now I have my 3 points, A prime, B prime, C prime, and I can draw my reflected triangle. So again, horizontal and vertical lines, we're just counting. Y equals negative x now, we negate the x and y coordinates to get our new coordinates. So again, that's a special thing to write down. The last thing we'll talk about are rotations. There's 3 different types of rotations we're going to do: 90 degrees, 180 degrees, and 270. And the easiest way I can tell you to do these is to actually physically rotate your paper. So if I want to rotate this around the origin, A is starting here at 3, 0. If you rotate counterclockwise your paper so that this quadrant is now over here, A prime will end up at 0, 3. Another way to do that is to negate the y coordinate and switch x and y after you do that. So if we negated 0, it's still 0, and then we switch it to be 0, 3. For B, we can negate 2, the y-coordinate, and then switch these two to get -2, -1. Or you can just have your paper rotated like I said, and this B would end up from this quadrant into this quadrant, and you can copy down the coordinates. Last but not least, C will negate the y value, make it +3, switch it to be 3, 2, and we get our coordinate. If I want to rotate using the switching the paper method, you can just turn your paper 180 degrees, or you can negate the x and y values and draw your new coordinates. So 3, 0 becomes -3, 0. -1, 2 becomes 1, -2. And 2, -3 becomes -2, +3. And we have our 180 degree rotation. And last but not least, for 270, you can rotate your paper 90 degrees to the right, or clockwise, or you can negate the x value and then switch x and y. So I can negate 3 and then make it 0, -3. Negate -1 and make it 2, 1. Negate 2 and make it -3, -2. And I have my new triangle. So I have one reflection, one rotation for you to do here. There's the coordinates x, y, and z. I will have a spot for x prime, y prime, z prime for both of these. So use your notes, use the lesson, try these two, and we can discuss them in class.